Today we are going to learn how to convert the bases of an equation so that we can solve the equation by comparing indices. Now, do you remember what is the name given to this term 9 here? Yes, this is called the base. In this lesson, we are going to convert base 9 to different bases. For instance, we can convert base 9 to base 3 because 9 is equals to 3 squared. And hence, 9 to the power of 4 is equals to 3 squared to the power of 4, which is equals to 3 to the power of 8. We have rewritten 9 to the power of 4 as 3 to the power of 8. And hence, we have converted base 9 to base 3. Do take note that 3 is actually a factor of 9. Can you think of a base that we can convert 16 to the power of 5? Yes, we can convert it to 2 to the power of 4 to the power of 5. Because 16 is equals to 2 to the power of 4. Using the law of indices, we have 2 to the power of 20. Can you think of another base that we can convert to? Yes, we can let 16 to be 4 squared. Therefore, 16 to the power of 5 is equals to 4 squared to the power of 5, which is equals to 4 to the power of 10. We have converted base 16 to base 2 and base 16 to base 4. Now, not all factors of 16 can be easily converted to. Can you think of some bases that we can easily convert to for base 64? Yes, we can convert it to base 2 because 64 is equals to 2 to the power of 6, and hence 64 cubed is equals to 2 to the power of 6 cubed. Again, using the law of indices, we have 2 to the power of 18. What is another base that you can think of? Yes, we can convert it to base 4. And hence, using the law of indices, we have 4 to the power of 9. Finally, can you think of one more base that we can use? Since 64 is equals to 8 squared, 64 cubed is equals to 8 squared cubed. And hence, we have 8 to the power of 6. We have converted base 64 to base 2, base 64 to base 4, and base 64 to base 8. We shall now try to solve some of the following equations. 4 to the power of x equals to 2 to the power of 5. As a reminder, it is sometimes easier to convert to the smaller factor. For example, base 4 and base 2 both have factor 2. And hence we will convert base 4 to base 2. Since 4 is equals to 2 squared, on the left hand side we will now have 2 squared to the power of x. And on the right hand side we will still have 2 to the power of 5. Using the law of indices, we will simplify the left hand side to become 2 to the power of 2x. Since the bases are now the same, we can compare the indices. Therefore, 2x equals to 5, and hence x equals to 2.5. We shall now look at another example, 2 to the power of x equals to 4 to the power of 5. Similarly, we will convert it to base 2. On the right hand side, we have 2 to the power of 2 to the power of 5. Using the law of indices, it will now become 2 to the power of 10. Since the bases are now the same, we shall compare the indices. And hence x is simply equals to 10. Now, looking at this equation, which base should we change to? Yes, some of you may be able to tell that 625 is actually 5 to the power of 4, and hence we can convert to base 5. Since the bases are now the same, we shall compare the indices. Therefore, x minus 2 is equals to 4, and x is equals to 6. Now, it is tempting to use try and error at times, but I would strongly advise against it, as you may lose valuable marks in your workings. To solve the following equation, can you think of a common base to convert to? You will notice that base 32 and base 16 both have factor 2, and we can convert 32 to 2 to the power of 5 and 16 to 2 to the power of 4. And hence, on the left hand side, we have 2 to the power of 5 to the power of x minus 4. On the right hand side, we have 2 to the power of 4. Using the law of indices for the left hand side, we will have 2 to the power of 5x minus 20. and on the right hand side we have 2 to the power of 4. Since the bases are now the same, we shall compare the indices. Therefore, 5x minus 20 equals to 4. 5x equals to 24 and x is equals to 4.8. Now, it is not always possible to convert to the smaller factor. So, how do we solve this equation? Can you recall about zero indices? Yes, anything to the power of 0 is equals to 1. And hence, we can rewrite the right hand side to become 9 to the power of 0. In this way, we have the same basis for both the left hand side and the right hand side. Now we can compare the indices. Therefore, 2x plus 1 equals to 0 and x equals to negative 0.5. Now, the notes on the right hand side is not always applicable. It is just an easy way to start us off to solving the equations. In summary, what have we learned in this lesson? We learned how to convert the bases of an equation so that we can compare the indices and solve the equation. For example, 2 to the power of x equals to 1 over 32. We will now convert it to common base 2. On the right hand side, we will have 1 over 2 to the power of 5. Is there a way to change the right hand side to look like the left hand side so that we can compare the indices? Yes, using another law of indices, we can convert the right hand side to 2 to the power of negative 5. Since the bases are now the same, we can compare the indices, and hence x equals to negative 5. Well, that's all for this chapter. Do remember to revise your law of indices regularly.